Hello, everyone, and welcome to today's demonstration. Today, we will be talking about machine learning and forecasting in finance. Okay, so the one of the main areas where machine learning is being utilized extensively in finance has been credit risk modeling. So basically, what we try to do with credit risk modeling is that we take a data-driven approach to identify uh, whether a borrower is going to default on his loan or not. We can further extend on this analysis to identify or predict the amount that he might owe at the time of the default, and we can have an accurate model that can actually help us identify losses and take estimates before they happen. So, why do we want to do credit risk modeling? We want to do credit risk modeling to identify and assign credit scores to individuals, and so that we can use those to predict their likelihood of default in the future. We want to identify the risk factors for banks and lenders for giving out loans. We want to have an estimate about the losses that we might face, or and get an understanding of the overall capital that the bank has, and what losses we can expect to have throughout the year. Or we might want to maintain the credit risk exposure and tune them according to different parameters that we might have. So how does machine learning help over here? So basically, machine learning is based on identifying patterns and gaining knowledge from those patterns. So this the data for this comes from different sources. This can be the through the borrower's social security number, or from the customer history that the bank might have, or from any other sources that are available. We can then also run an analysis for the using machine learning, and we can develop forecasting models for the credit risk assessments, which we'll see later in action as well. We can also analyze data from different financial institutes for small to medium sized borrowers, but this is for uh, enterprises, small and medium sized enterprises, instead of individuals. So, how do we go about building and deploying this type of models? So, let's say that we have some financial data available to us, and what we do is that we want to do two things over here, and we will see this entire flow in action as well. So, we want to identify what whether or not the borrower is eligible for the loan, whether or not he would be able to pay the loan off or not. And we also want to identify, like, if someone has come uh, to file for a loan, what should be the term that we should offer to him, like how long should the loan last. And this is based on a number of factors, as we'll see as we go along. So, but basically, this is based on the social security data that's available, the individual's salaries, his current loans from different that he has filed for from different institutions, and all related data. Now, the great thing about ML models is that they can be deployed with the help of RESTful APIs. So, this RESTful API can then be integrated into any application that we might want to run it with, and we can also retrain the data on retrain the models on new data that's available. And this data has to be kept in a different database for that is solely be used for this. Let us have a look at the demo now. So what we did here was that we took some open source data from the Lending Club, and we drew some initial insights from that data. So over here, what we can see is that we had two terms for our loans, either a 3-year term or a 5-year term. but and we had different interest rates set for each of the loans. So there was 7%, 9%, 11%, or 12%, and so on. So, and what we found out was that the most common applications for loans was filed for a term of 3 years with an interest rate of 15%, followed by 14% for 3 years and for 12% for 3 years. And basically, there are very few 5-year applications available, but there have been a lot of default credits over here. So one of the reasons for the defaults might be the high interest rates or the longer loan terms. If we see according to the proportionality, um, we have more 3 years loans being paid off more quickly rather than 5-year loans, which are almost equally distributed with regards to default and non-default ones. And if we see whether the loans application status in total, we can see that there were about 20,000 data points that were not eligible or that defaulted on their loans. And there were over 120,000 uh, data points which were eligible for the loan. Let's move on to the machine learning sides of things. So, in order to predict whether someone is eligible for a loan amount or not, let's say that I want to file for a loan of 5,000, and I want to pay that loan back in 3 years, and I want it to be an interest rate of 7%. But my annual income is, say, 30,000. So if I add my social security number, what I will get over here is that I am eligible for a loan. But let's say that let's say if I want to file for a loan of 500,000 and my annual income is 20,000, then I would not be eligible for a loan. So these are actually the basic things that depend on. So what the model does is that it takes into account the loan amount that I'm asking for, the period I want to file for the loan, my interest rate, my annual income, and based on my social security number, it pulls up data from the database regarding my credit scores, my current loans that I have already taken, and any other credit related data that's been available. Okay, and if I want to identify, like, as a lender, I want to identify for how long should I give someone a loan, then that can also be done with the help of ML. So, for example, let's use the same numbers. If I want to file for a 50,000 loan at an interest rate of 7%, and my annual income is 30,000, and my social security is this. So the model predicts that it would be more feasible if I am granted a loan for 5 years instead of 3 years, so as to maximize profit that the lender is earning, as well as to make it more feasible for me as the borrower to pay the loan off in the given time.